Alright guys, so we're gonna skip example 1. We're gonna do example 2 together, and then you can do 3 on your own, okay? So 2 is a good one, okay? It's a pretty long example. So let's do it. Okay, first step, identify the base. Oh, it's a square again. That's pretty nice. Okay, this is square array. And let's get my formulas here just to have them. Surface area 1/2 perimeter of the base times slant height plus the base area. Alright, the one thing we know is that the height is 10 centimeters. But the key part here, inside, right, this triangle here, that 60 degrees is going to help us out a lot, okay? When you see that 60 degrees, there's only one thing that should pop in your head. And that is 30, 60, 90 triangle. So here's 60 there. Okay, we know this is 10. 30, 60, 90. Okay, x radical 3, 2x. Okay, so I have the 60. Okay, the 60, opposite that is the 10. So how do I go from 60 to my 30 degrees? I need to divide by radical 3. This is where you gotta rationalize the denominator. 10 radical 3 over 3. And that right there is gonna be, I'm just gonna move it to get more room. Right here, 10, oh snaps. 10 radical 3 over 3, okay? Boom, right there. Okay, so now we can actually find the base now. That this base right here is actually going to be 2 times that, right? Because again, it's a regular pyramid. So this center to this edge is always going to be halfway. So we just got to times it by 2. 20 radical 3 over 3 is the base. Okay, so now once you have that, we can identify our base now. So let's find the base area, which is really the fact that it's a square. It's going to be 20 radical 3 squared. Put that in my calculator, approximately 133.3 repeating. The perimeter is 20 radical 3 times 4. Oh, wait. Ooh. I'm going to fix these two numbers, guys. It should be a 3. These should be a 3. This answer is still correct because I was just looking at my solutions. Okay, so this answer is correct. I just wrote it down. I just wrote these two numbers down incorrect. So it should be 3. And this here is 46.188 approximately. And then the slant height. Okay, so this slant height here, I'm gonna get orange. This slant height is part of that 30, 60, 90 triangle. So to find the slant height, that's opposite the 90. So if it's opposite the 90, I need to take the value opposite the 30 degrees and it times it by 2. So 10 radical 3 over 3 times 2. This would get me approximately 11.547 for the slant height. And now we can finally put everything together. So my lateral area is 1/2. The perimeter of my base is 46.188. The slant height is 11.547. This will end up being 266.67 centimeters. It was 67, but I'm going to round it to 266.7 centimeters squared. Okay. And then for my surface area, it's always smarter to take the non-rounded number, right? If I'm trying to find the most accurate surface area, plus my base area, which is 133.3 repeating. This actually works out nicely. This is approximately 400.0 centimeters squared. Okay, don't forget that 0.0 because you are rounding it, right? The answer is not 400 flat, right? 400.0 centimeters indicates that we were rounding this number. And boom. Okay, there's your answers. Please do number 3 on your own. So pause the video right here. Alright guys, so let's check your answers here. Just you can follow along. Okay, so key step, identify the base. Okay, that base here is a pentagon. Okay, as we call back the formula for polygons, which is 1/2 times apothem times perimeter. Okay, and just looking at the information, they actually gave you everything you needed. The point of this problem is to get that little throwback, okay, for the formulas for regular polygons. Okay, your apothem right here is 6. The perimeter, you're going to take 8.7 right here, the perimeter, 8.7 times 5, which gets you 43.5. And they actually gave the slant height as well, which is 15. And then from there, you can just plug it in and solve for your lateral area, and then solve for your surface area. Okay. All right, last one here. Not a new formula, but I mean a new shape, right? It is a cone. Okay, so cone, circular base, and a vertex. The axis of the cone is a segment with the endpoints at the vertex and the center at the base. Okay, so the axis, boom, right here, is also your altitude. Okay, and you can see oblique, right? Oblique means that it's shifted to the sides, right? Like your obliques are on your side, so it's shifted to the sides, right? Or like slanted. Don't worry about it too much. Ultimately, it's still gonna be the same formula. Okay, so do not worry about that. All right, so let's really plug this in here, okay? Lateral area, we know, is 1/2 perimeter of the base times slant height, okay? So this is kind of like a pyramid, right? It has a base, right? It has a base, and the lateral area all meet at the vertex, okay? So it's still very similar, but now, what is the perimeter of this base, right? The perimeter of this base is a circle, right? So we're dealing with 2 pi r, right? The circumference. So if I plug that in here, 1/2 2 pi r times the slant height. What's going to happen here? The 2's will cancel, and you're actually left with this nice formula. Boom. Pi times radius times slant height. Okay, that's it. So you can either memorize this, which I don't know if you need to. I would think just memorizing this is good enough, because once you memorize this lateral area, which is for a pyramid as well, then you just gotta identify the base to be a circle and you plug in circumference. Okay, so either or, you can strictly just memorize this easily, or just know the foundation and you can plug in your circumference. And so surface area, same idea. 1/2 perimeter of the base times slant height plus the base area. We know this was simplified to pi RL, and the base area is pi r squared. Okay, so boom, your 2 formulas. Really, it's the same formula, guys, right? It's still this formula, but you're just plugging in your circle formulas. Okay. One neat thing I want to show you guys. Okay, this is also derived in a pretty cool way. So this is extra. Okay, I want to write the word extra here. So let's focus on this lateral area. Okay, we're just focusing on the lateral area of this cone. So ideally, I can really break this up into, anybody guess what shape? Boom, triangles, right? I can break it up so often where really this becomes like flat, okay? So ideally, this is just a whole bunch of triangles put together, right? So everything in red is my slant height, okay? In blue here, what would blue be? Is the circumference, right? This circumference here, right? So the circumference is what? 2 pi r. Okay. So fun fact, if I want to find the area of all these triangles, right? So the area of all these triangles is 1/2 base times height. Okay, so how can I break this down here? What's the base? Right, if I add up all these triangles, all these bases, base, all these bases, those bases are the circumference, right? Boom. The circumference, and then what will be the height of all these triangles? All the height would be the slant height. Boom. So now once you simplify this, you can end up getting the lateral area formula. Okay, so just another way to derive it conceptually. So again, that's just extra. If you didn't understand this, that is totally fine. Okay, we're gonna do one example and that'll be it. Okay, cone is easy. All right, identify the base. It's a circle, yay. Circle, surface area, still gonna be the same thing, right? Plus the base area. Okay, do I know my slant height? Oh, I do. Slant height is 13. That's easy. What else do I need to know? Well, for these, right? 1/2. The perimeter is 2 pi r, right? The perimeter of the base here times the slant height plus pi r squared. And if I want right now, let's cancel out the 2's. How do I find the radius? Oh, this is the radius here. Draw out the triangle. Radius, this is 12, this is 13. Do a little Pythagorean theorem, or if you're math savvy and remember that it is a 5, 12, 13 triangle, right? 5, 12, 13 triangle, then you know radius is 5. Plug it in. Slant height is 13. (65 pi) plus 25 pi. Surface area is 90 pi centimeters squared. Oh, I actually forgot to solve for the lateral area. But as you know, lateral area is just part of the surface area. So lateral area, 65 pi centimeters squared. Okay, and I know this is round to nearest tenths, but we did talk about that before. If you get a clean number, right, like 90 pi, just leave it here. Okay, no need to round it. Okay, obviously if you get like 90.62538 pi, then yes, just multiply it out. But if you get a clean number, just leave it like that. Okay, and on your test, it'll be more specific as well. All right, that is it, guys. Good job.